Yeah, a warm welcome everyone. Good morning, goedemorgen, whatever we call in Dutch. Yeah, welcome everyone. First, a confession that people told me that blend in local, right? Pardon me if I see super excited. I had a stroop waffle in the breakfast and that's kicking in, all right? With that said, let me explain you what we are going to discuss today. This session is about securing AI pipelines, Kubeflow on Kubernetes-based AI infrastructure. We already had a great session, keynote on Kubeflow, right? You might have attended. So it's just an extension to that. We'll see how to create, we'll see a full journey, like how a Kubeflow pipeline is created, how we implement that pipeline into the Kubeflow infrastructure. Then finally, we'll create an application that will use that model to generate the response. Yeah, let's get going. Before that, a quick introduction about myself. I'm Abhinav Sharma. I'm a site reliability engineer at KodeKloud. So the one who don't know, KodeKloud is an ed tech which provides courses and hands-on labs on everything which is in cloud native and AI spaces. So I am the person who is handling 10,000 user requests per minute and making sure that the infrastructure stands robust, and we are also aligning with our cost. I'm also a Microsoft MVP, which is an award given to the individuals who have done contributions in AI spaces, and a GSOC contributor with OpenSUSE, and a GitHub Campus expert, and done 21 different certifications in majority of the cloud providers, including AWS, Azure, GCP, and now the Linux Foundation certificates are also added into this stack, which I forgot to add. All right. A quick sneak peek, apart from being a techie person, I had a dog named Sudo, and his name is completely dedicated to the most used command in the Linux. So I love that command, and I love my dog also. This is a quick about myself. Now let's not waste much of your time and just dive directly into what we are here for today. So the agenda for this session will be, do you know we have different kinds of models, like language models, we have image generation models, we have audio models, we have video encoder models, different kinds of things. So today, we are going to see Stable Diffusion, and we are going to use Stable Diffusion and train it on a Kubeflow. The same thing can be implemented on LLMs, and if you want to build any machine learning models from scratch by your own, but Stable Diffusion will be the case for this session. Second, we're going to see what is Kubeflow and how we create Kubeflow pipelines. Third, we'll build a Kubeflow pipelines on Kubernetes clusters. And finally, we'll build our own text-to-image generation app. You have used so many applications like Delhi Image Journey to generate the applications. Those tools are paid, we know. So how you can build your own on your own premises, but yeah, it needs infrastructure, of course. But yes, you can build your own text-to-image generation app after this session. I'll also share the link of the application that we are going to build. All right. So first, it's important to understand what is Stable Diffusion for the ones who have any idea about it. So it's an open source generative AI model which is used to generate the images from the text prompts. So below you can see I have generated few images from our own image generation model that I'm going to show. So I've given a prompt, for example, generate image of a cute Bernese dog. It generates that for me, an architecture design, or a New York skyline, anything we can just build from the image generation model that we are going to see now, all right? So this is a Stable Diffusion for you. Quick into its architecture first. So what is a Stable Diffusion architecture? So yesterday I visited the Vincent van Gogh Museum, so I thought to take that example only. So let's say you're given a text input prompt, painting of a New York City by Vincent van Gogh. All right. So what happens at the end, like the back end, there is a clip text, which is a transformer-based neural network. Clip text basically do the token embeddings of what you've passed as a phrase, as a prompt, right? That token embeddings are then passed to the unit and the scheduler. So what does these two components of the stable diffusion model do is, unit basically tries to generate the images based on the tokens. So for example, let's say New York City is an token, so the unit will try to generate the image of the New York City only. Now what's the task of scheduler? It's like a check. The check which will be sitting on top of unit, so that it gives the freedom, it defines the freedom. So it stops unit to do the creativity on its own and stick to what prompt says. That is what the task of a scheduler. Finally, these two components creates the image tensor, which is readable by your model, but not readable by the humans. So we have a auto encoder decoder that basically decodes the complete image tensor into the fully formed image, which you can see on the left side, right? So that is how a stable diffusion architecture works at the back end, right? So now the next thing is Kubeflow. So what is Kubeflow? We already had seen that. Just a definition, like it's an open source platform which is designed to simplify and streamline your machine learning workflows. I have given different talks at different countries, and what I saw is people know about how to create machine learning models, but they do not actually concerned about creating an entire machine learning systems. So what a machine learning system has, a reconciliation or a retraining logic. Let's say if any anomaly comes in and you want to retrain your data, I think and I propose that's the best way you can use the Kubeflow there. So it actually, let's see the diagram. First, we have a data. So we have different sources of data from where we take the data, and then we train the model. So we have different libraries like scikit-learn, TensorFlow, Keras, you guys have heard of. So we use them to train the model. Finally, we deploy the model and serve that on the endpoints using the K-serve. And then we monitor the models. Monitoring needs, it is the step where we do the reconciliation. If you are not satisfied with the response, you can just send again the model to retrain with adjusting or hyperparameter tuning and things like that, right? So this is how a Kubeflow works, right? So in this demo, I'm not showing you how to train or create your own machine learning model. We just do the inferencing for the sake of simplicity. So I will be using the already trained model, which I have imported from Hugging Face. That's a CompV's stable diffusion model. We will do just the inferencing. But if you want to create your own model, it's very easy to create everything in form of steps, like training, deploying, testing. Everything can be handled within the Kubeflow once you define your pipeline structures, right? All right, so what will be the outcome of the demo? After this, I'll jump directly into the demo part, right? So first, we'll build the pipelines on our Kubernetes stack. Second, I'll show you the things of how to secure your pods, applications, storage locations from unwanted traffic. Now, a Kubernetes engineer or a DevOps or a cloud engineer would know about avoiding the traffics, but when it comes for the AI engineers, they only know how to write and code that works for your AI applications, but they don't know what and how you can build your better AI infrastructures. So that we'll see. And finally, we'll build a secure text-to-image application, which is not in terms of ML pipelines, but yes, there are some do's and don'ts that you need to follow when you build any image generation application for your needs, right? All right, so the first step, we'll set up a Kubeflow pipeline. In a bit, I'll show you the Jupyter notebooks where we are doing just these same steps. It's just the code snippets for the ease I have just shared. So first, we'll do the Git cloning. It's the step where you need to install the Kubeflow. There is a documentation out there, but this is the one I used to install the Kubeflow on my AKS cluster, Azure Kubernetes Services. And this is a simple customize command, which I just used to install everything. So basically, Kubeflow is a stack of so many services we know. There's Kubeflow pipelines, there's Kserve, there's run, experiments, and things like that. So using this, I install the entire stack. If you had any specific use case, you can just go and you should not install the components which are not in your use because it's a heavy resource, right? Now, how a pipeline is created, in our case, in the demo, first stage or first component is prepare and upload the model. In this, I will be importing the model from the Hugging Face, and then I'm saving that model in my local cluster on the MinIO. The one who don't know about MinIO, it's storage or object storage, like S3, AWS S3 if you have used. So we are storing that model into the local so that I can do the inferencing on that model and that model can serve from my local infrastructure instead of doing the invocations from the internet. Second, I'll generate the sample image. The second step that you can see there, it's generate sample image. This step is basically where I'm doing the actual inferencing, setting up the CFG guidance scale, or you can say the CFG classifier free guidance scale, which represents how much your prompt is followed by your model. That is the CFG. So these things will be doing in this stage. And final stage, once we are satisfied with any deployment profile, like all the parameters we said that, yes, this is what I want, we'll finally set up that deployment profile and save that model again onto the MinIO so that further we can use it in the image generation. So yeah, these are the steps. Let me jump onto the demo part now. So yeah, this is the Kubeflow authentication. I think you guys have gone through this. This is DEX. DEX is basically offered by Kubeflow directly. It's a good OIDC. I see people generally avoid this because DEX queues can overload your clusters some of the times. But you should have any authentication, OAuth or OIDC on top of your Kubeflow infrastructure. That's the first advice. A layman's, but still people avoid this, so it's important. Let me zoom it a bit. Okay. So this is the notebooks, and here I'm going to connect to the notebook which I've created. All right. So I think I don't need to give an introduction of what a Jupyter notebook is, but this is generally the code which we are going to use to generate a final YAML file. This YAML manifest is basically the pipeline, actual pipeline that is going to run in the Kubeflow. So first step is to install the required libraries of, I'm using Python, so it's the required libraries I'm using: Diffuser, Transformers, Torch, Hugging Face, and KFP means Kubeflow pipelines. I'm not going to run them because some libraries takes minutes to hours to load, so that's why I already loaded them. This is the components. As I shown you, the first components is to build and prepare the model. Here is the same thing. We are saving things onto the MinIO. And the second stage is generating the sample steps. Here I'm doing the inferencing. Like here you can see I'm passing the inferencing and all those parameters. I'll show you those things bit when we are exporting these as an actual pipeline. And final step is basically the uploading that deployment profile, like all the parameters that we get from the previous step are now used and uploaded to your MinIO again. And finally, all these things I'm using and creating a Stable Diffusion ML pipeline YAML file. So how this file is looks like. So this is the file. This entire code that I've shown you is just to create this file. You can directly create this, but if you see the content, it's kind of a thing which is less readable. That's why we generate the pipelines usually from the notebooks or some other sources. So this is the entire pipeline anyway. And now we are going to use this pipeline to create our own, run our own experiment. So how we can do it, I'll go to Kubeflow dashboard. This is the pipelines section, and I need to upload a pipeline. So I can give a pipeline name AI dev pipeline, yeah. And I need to upload a file, so I'll choose the file from my local. This is the one, open. And yeah, this will import complete manifest into my Kubeflow pipelines page. And these are all 3 steps that we are going to use to create the inferencing and build a deployment profile for us. Right? The first step is prepare and upload that we already discussed. Second, I also have a slide to explain. Yeah. So yeah, these are 3 steps. First is prepare and upload, where I'm preparing and uploading. Second is generate an image. And third is promoting the deployment profile. This is the actual task that we are going to perform. All right, so then you need to create a run. This run is actually, here you can see, these are the parameters that I'm talking about. So these parameters are passed. Guidance scale means the freeness that we give to the model to generate an image, height and width of the image, min-io access key, secrets. These things don't need to be passed into the pipelines directly, but for the demo purposes, I kept them there. And then the number of inferencing steps, I kept it 15. You can adjust if you want more refined outputs. And the seed value and the prompt. So this prompt is basically, this is the prompt which will generate an image for us. And finally, we need to choose an experiment. So I had 2 experiments in here. If you want to create one, you can just go to experiments tab here and create your own experiment. Let's name it AI pipeline EXP. All right. Right. Okay. So I'll go back here. I can choose this experiment. So every deployment that we do will be counted under this experiment profile. And finally, we'll start this pipeline. So as it is a ML pipeline, so it would take time because it downloads the model, it creates those inferencing, and finally uploads the model to somewhere else, like in our local storage. So these things take time. My steps are cached, so some might processed early, but sample image generation would take time. So I'll show you the run, which is already there. All right, so these are the steps which are generated, and you can see all the inputs and output parameters that are passed into the pipeline, and the task details which says the pipeline is completed. Logs would be, logs would be there because I still have these pods running. So these are the logs, actual processing which is happening behind the hood for every step. So in Kubeflow, every process, every component is a separate container, you can say, which is running as a steps. So input for a step is an output for another one. That's the thing. So this is how a pipeline is created and doing all the inferencing. Now, where you can find, so as I told you, everything is in my min-io browser. So I can go here, can type in the password. All right, so everything I'm saving is in this bucket, Stable Diffusion bucket, generated images. And these are the images, every time inferencing is done, each image is saved into this bucket. So I can download it, and we can just see what it generates. So this is from the last run that I did just before the session to save the time. So my prompt was create an image for a sunset from the ocean. So this is what. So if you don't like the output, you can just improve on your inferencing steps, your guidance scales to match. And this is how you can get a better deployment profile, which works for your case. All right. So yeah, this is how you create a pipeline, you test a pipeline, and where the model is uploaded. In the same bucket, I have uploaded the models in this directory, and this is the model and all of its component that we discussed, like unit, scheduler, text encoder, tokenizer. All those steps that we have seen in the architecture are now directly used from the bucket. All right. So just one more thing. This is how Kubeflow pipelines are created, but one more thing is there. So when you see, there is a logic in Kubernetes. I don't know if you guys know this. Every pod can communicate to each other, right? Everything can be shared between the pods. So how this can be an issue for us? So this is another application. This is another pod which is running. So this pod can access each and every data which is present in my min-io pod. So this could be a breach. Why? Because everyone can come and take anything from your data sets, anything from your buckets. So how to avoid these kinds of things? So here we have a concept of network policies and authorization policies. This is something which is needed when you work in the environments of ML pipelines, and which is neglected generally by the people. So I'll show you that as well. So min-io. And this is the security policies. So if you guys don't know about network policies, so network policy is based on the tags which are applied to the pods. It restricts the traffic. What traffic can go in and what traffic can go out is the concept actually done by the network policies. So here, if I run this network policy, cd menio, right, kubectl apply -f menio. So this is a typical kubectl commands. I think people who work with Kubernetes daily should have seen this. So I apply this policy, this is created. Now, if I refresh this, you can see the breach is still there. Generally, why this has happened? Because there is also a concept of authorization policy. If you have heard of Istio service mesh, so Istio works on layer 7 and network policies works on layer 4. So things which are passing from layer 7, which means the Istio layer would not be restricted by things like this. Network policies won't work in that case. So that is the agenda, to show that even if I apply the network policy, the pods can access the data. So for those scenarios, you need an authorization policies which works on the layer 7 for you, and they are directly applied on the service accounts, not on any tags, right? As you can see here. So now if I apply this kubectl apply -f istio, yeah. And now if I reload the application, hopefully it should not load now. So it's taking time, which means our application is now not accessible so you can see the security is working, which means we have blocked the traffic from the layer 7 itself. So this is about the network policy and authorization policies that you should consider when you design any machine learning pipelines. The third thing is about the application itself. So how a machine learning application serves for us. So for that, let me run this application that I've created. It's a Streamlit application, image generation, yeah. So it's serving on 8501, cool. Okay. So this is a normal Stable Diffusion based image generation application. You can pass in the prompts here, anything you want to generate, and this will not invoke any APIs from the internet, and your traffic remains within your cluster, within your premises, because it will be going to call this model that we have in our Menio bucket and generates the image for us. But there are a few things that you need to consider when you create any images. First, a rate limiting. If you are creating an end-to-end user-based application, you should have a rate limiting that how much a user can use when they create any application. So let's say if I try to do this, so it gives me a rate limiting, like I cannot create more than 5 images per minute. So this is first thing you need to create. And the second, the most important, is the content filtering. So interestingly, when I just created this model without any rate limiting, I found that I can generate anything, like copyright images, images which show some violence, right? Anything I can create and build from the raw models. So that's why I need to have a content filtration using things like regex, or you can apply advanced DB Chroma on your database. You can have something. Most of the time, I find the regex or the patterns recognition is the best way to avoid these things. So yeah, you can just generate the image. I'm sure image generation would take time, and I have rate limited myself. So I won't be able to generate the image, I guess. No. Yeah. So, and the third thing is user isolation again. So every user should have the isolated space so that I cannot see yours data and you cannot see mine data. So these are few things which are not related to the ML pipelines, but for an AI engineer perspective, if you are designing an end-to-end application, it is important to understand and implement these 3 features as well if you want to design your application. Just a second. All right. So yeah, I think is my demo finished? Yeah. So yeah, a quick one and a short one. So with that, I'm done with the presentation. The image generation application that we have created, I think it would take time to generate an image for us. but let's see if it generates. So, but it is working fine. So if you want to create your own image generation application, this is the application link, which you can just go and build your own. All the prerequisite is you need your own Kubernetes cluster to host those things. And if you have any things in mind, you want to discuss something, you can connect with me as well on LinkedIn, and I would be happy to assist you and work with you on this. Yeah, thank you, everyone. This is it.